So, sorry. Hi everyone. Hi, welcome back to my YouTube channel. So, in today's video is the second part of uh, the videos of the first search and lowest common ancestor algorithm, where I already showed the visualization and the problem statement understanding in the first part. So, as I said, in this part, with the second one, we're gonna implement the code totally, and then we also check the test case and try to run it with power near. So, we finished at this line of code, and let me explain briefly, really fast. So we already define the main function and the process function, which is also the main functional one, the primary one. So this one is we look through the n number of houses, and for each we have uh, n minus one number of rows. We have n I mean like this one should be n minus one. N minus one. We're gonna give allowance to saving changes. So we're gonna assign the value for this custom log with the value of actual log, log of n. So this one is the height of the tree that we're gonna traverse. We're gonna call the dfs function, which is the custom function that we will make later on during our implementation. So I just so this one is called find the ancestor ancestor find ancestor relate or calculate ancestor. So after that we're gonna read from the table the tree with the number of queries. And we're gonna follow for the tree. If it start from I equal to 1 to I equal to 3 with the I business increase. We're gonna Because we're gonna find out the minimum number, so we make the answer to be a really big as the initial state. So it's some like 1e18. So 1e18 means that it will be in binary go to the left 18 times, so it become 10 power by 18. So and with the multiplication with this phone number, this number 4, so it's we assigned to the nth variables. So for the thing, so we're gonna see the a1, a I2, a3 continuously with 3. So we're gonna for loop to make the permutation, I mean the uh, relative permutation of these three. So I'm gonna make a one two nested for loop in in J. That's already divide I. So make it J one from 2 to J less than or equal to 3. And we're gonna increase the tree and let's continuously for loop. So we need to use double transcript. So we need a basket. I'm going to use new variable k to loop from k1 to k less than j. So this made the permutation, the relative and not repeated permutation between the three from the input. So inside the nested loops, we're gonna define a U, which is for the to find out the lowest common ancestor between the A3 and AK. AK. So because we only have uh, three numbers to find to make to I mean like to find the output, so we just find the one lowest common ancestor between the two among these three, so that we can use the common ancestor to compare to find the another common ancestor between the that we found out and the AI or on the another I mean the remaining number between these two. So yeah, so that's why we gonna define a variable u right here. Actually, we can make it like this. Just and gonna make and we're gonna assign value to an variable which is short for answer or the result of our code, and we're gonna compare it and to figure out the norm number. So this AC function is used to calculate the prefix sum from the node A, like one element from the A array to any houses interconnected. So KC is the U, the A1 plus with the KC of the U from A2. Yeah, so and the plus the KC from U to A3. Then we can identify the lowest common ancestor of every inside the array with each of these three numbers. We're gonna give it to the minimum for the answer. So that's how we can find out the answer. So after this nested for loop, so this outside this nested, the two nested for loop, we're gonna return back after each queries. So we're gonna return the answer. So we're gonna see out everything because the void function. So we're gonna see out the answer, the end application. Uh, so after that, we're gonna define the remaining functions, with the like, respectively have its own functionality. And for first of all, we define the void function called DFS, which will be traverse the tree from the imaginable nodes that I already explained in the last videos. The first one of these two videos, and this one is the second part where we give the code, and for this weight we're gonna use error because it's gonna exceed the limit of integer. So this one is the parents, um, parents, yeah, parents, the S parents. So we start from the U node with a level of parents 0. Now it's gonna be equal to a pair of B and W. So P is the destination which connected with the new house. B is another house in the list of connection, and P is the weight or the length of the road between them. And we already have an array here to find the I mean like the temporary variables, but in this case we can use an array to mark all the nodes with some values. So as I already mentioned in the last videos, T is used for the temporary variables where we can check where we can check the height of I mean like the subversion of the G in the position of the node. So with this array we can make some condition to check if a node is the upper node of another one. So this one is this has its own value and benefit. So for the GU, it's because the pair, so we're going to use the FS, which short for first divide here. Plus, we're gonna plus H. H also we also divide, and actually we need to make it like in the initial value. So we is 0. And increase the H. We cannot use like I think H plus A or H plus is the same in this case. So I'm gonna do a for loop, nested for loop from I is equal to 0 to I is less than GU. As I already mentioned in the last video, uh, these J vectors is used to store the connected nodes from the current node U, the U node. So the I plus plus. So we can check the condition here with the JU dot GUI dot post is not equal to B, then we not gonna like do like two dimensional. So after we reach B from U, we don't need to we reach B from U, we don't need to reach U from B again. Like this will make the DFS a mess. Like we cannot find out the condition to break this recursive call. So actually we just call the DFS function again is the recursion. So in this level of recursion we're gonna put the GUI first and U is the B in this case. After this iteration it become B and this first become U. So from B to U with this recursion level, and the next level will be U to the next connected node from U. So this one is gonna take some weight with also the length of the road, which in the short per second, as we already defined. So for the TU dot second is gonna be equal to the increased value of H. I'm gonna make another function as I already showed here, which called Ancestor. So short for calculate the ancestor. So make a for loop inside them, make the mistake for loops, use the variable k equal to 1 and to fix the maximum height of the tree with also the custom block way I already explained. So it's not a column, single color. It needs to be like um, um, like the double column, not the middle column. So let's take the plus the semicolon, then it's a semicolon. So flip it to the end and increase it. So gonna calculate the ancestor. I need the prefix sum that I already explained in the last videos of the part one. So I'm calculating the prefix sum from the node to the imaginable node. This one is the score thing. It's called parent summary. So it's parents. Start from the node I to the level of the parents of K. Is equal to a new pair. A new pair of the parents of the parents. I mean the parents is so confusing, but I think you should take some time watching this video to understand what I'm writing and what I'm trying to say. So this one is the higher level of the tree. So we find the parents of the parents in the second higher level from the node I. So the first and this k minus one. But first the parents will copy this to save time. In this case, is used for the weights of the length of the road plus the weight in the current road. So it's gonna be from the node I to the previous level plus second is the weight. So after that we already have the prefix sum from of the cumulative sum of weights from one node to the imaginable node so the highest node in the tree. So after that we're gonna make the upper function. Here's the polling function is on the is upper is upper. So in this function we're gonna check if the node view is the upper node of V. And we have return single return with TU was less than or equal to TB dot the first, as I already mentioned in the last videos, is the current condition to check if one node is the upper node of the other. So this TU dot second is more than or equal to TB dot second. So after checking is upper, we're gonna use that inside this newly created function. This one is RCA, is short for lowest common ancestor. So we have put some parameter to it. Let's check first if the upper, if u is the upper of v, gonna return directly the v, the u, because u is the already the common ancestor after this checking process. Yeah. So after that, we also check if we copy this to subject. We check but in positive, like the opposite direction. So this one is the B and this is C. So if the B is upper, so it's also the lowest common ancestor of U and V. Because why is it uh, you know, do a for loop, simple for loop, to every level of the gene. So custom block, we're gonna go down to 0. So because we make the previous sum from the top to the bottom, so that we need to go in the opposite direction from the lowest to the top. So this one is a minus minus. We need to check if of u, the level of k, of course, is not equal to 0, which is not equal to the imaginable node. We're gonna check also with the if not parents of u, k, of course, and v, so that u is not the like the parents of u in this k level is not the imaginable node, and so it's not the upper of the v. Then we gonna assign a new parents to u. So u will become its nearest parent. So now we assign the parents of u to u itself. So you paste that first this, so that we know we can find out the common ancestor. For visualization, I already put in the videos. So after this implementation, we're gonna return the parents of u 0. It's the mentionable node. No, I mean like u0. u0 uh, is the nearest nearest is the nearest parents from u, the letter u, the variable u. So that okay. So we make the last function, the another two function. So this one gonna by set a get function, and because this get function is gonna be used to used inside the function AC, is used to calculate the cumulative sum from the node u to the node a1, and for so with the a1, a2, and a3. So we're gonna define a new variable, a new function here. So put inside the view in defining the condition here. Return is 0, u is equal to v. Okay, so obvious that if u is equal to v, so there's nothing to calculate, so just return the variable. So the n is equal to 0. for in case to lock. We're gonna traverse the tree in different levels from case equal to lock to case equal to 0 with the case decrease. So we're gonna check if of u at the level of k of course not equal to. Actually, we can copy the same condition. So after the checking process, we're gonna calculate the answer. You know, assign the assign values to the answer variable. So it's for u a second. So answer also the cumulative sum of each total past cost and like past length from u to from u from different level of from the u like the prefix of the parents uk first. So we're gonna assign the parents of u to u if this satisfy this condition. So let's have the answer was equal parent percent is the current the nearest length of the row from the u to the nearest parent itself. So this get is to calculate uh, so after that we're gonna divide the AC function. We're gonna put them two variables. Okay. So if the upper of u and b uh, so if u is the upper limit of b, get the function of u and b. So we had the same thing that we're gonna check in opposite direction. We're gonna get the cumulative sum between b and u. So after that we're gonna so if v like either v or u is upper or the common ancestor of each other, if we not satisfy those conditions, we're gonna find out the nearest or the lowest common ancestor between u and v and assign to this variable r. You can actually do it like a ancestor lowest common ancestor ancestor. Actually, for short, just UL. Let's go to LCA because I already implemented. So the will be return the u plus the get so that our implementation of code is already uh, in function. So I just check if everything is going well or is having any errors. So we have some errors right here. Aesthetic visualization before them. So now we're gonna fix the errors. I think that this compiler that will not accept the define process. So we just the function of declare in this code. Go to the see if we have any more errors. So the parents is the global variable, but why is say not in the scope defined? Um, parents expansion of network. I think we're gonna comes to the AI terminals. Because I think this compiler will not accept some defining stuff here. So we should check it with the help of AI to help us to save time of fixing this code. Because we already have the idea of the code. So if it's AI is making stuff messy, then we can fix. Otherwise, it's not it's not a pen. Uh, hmm, oh yeah, AI is very intelligent, but not in our case. But in this case, can help see, you see, after using AI, already got all the error deleted. I got, I'm afraid. It's okay. Let's continue. If the output is 3 and 4, then we are good. 2, 4, 1, 2, 3. I'm typing. Oh yeah. 1, 2, 4. Okay, so our implementation is correct. Also, we have the idea how each function works and how to make some arrays vectors to store values and how to use this as a trick to reduce the performance cost. So use these three light to reduce the how can and then we already learned how to break down uh, the code into multiple functions so it make more functional and more readable. So that's it for today's video. So in the upcoming videos I will mention and with implementation and definition uh, in many hard problem or intermediate problem in terms of a lot of technology aspects. So just stay tuned and subscribe to my YouTube channel, and you can give it a like if you uh, see these videos positive and beneficial for you. And yeah, I see you in the next videos.